Welcome everybody to this latest edition of In-House in Focus. I'm your chair for today's session. My name's Alex Newman. I'm a partner in the intellectual property team here at Mills Reeve. Today, my job is simply to chair the session and do a bit of housekeeping and do the introductions. So in a moment, once I've done that, I'm going to hand over to Simon, who's your speaker today. Simon Thompson is the Chief Technology Officer here at Mills Reeve. Part of Simon's role here is looking into and assessing how Mills Reeve can use AI for the benefit of the firm and its clients. So Simon's going to address some of his learnings with you today. He's going to be looking at some of the opportunities, some of the challenges, some of the current views on best practice relating to the use of AI in the legal landscape. One thing I would like to stress is that this session isn't primarily a legal session. It's going to be looking more at some of the operational and technical issues associated with the use of AI, particularly how these AI tools work. I know as lawyers, quite often we're considering the legal considerations pertinent to the use of AI tools, but quite often there isn't very much understanding of how they actually work. So hopefully with Simon's help, after the end of the session today, you'll all be able to consider and assess the legal implications of the use of AI within your legal operations in a more appropriately on a more appropriately informed basis. So before I hand over to Simon, just a little bit about housekeeping. Firstly, there will be a recording of this session made available afterwards. The presentation, which you'll see, which Simon will speak to, will also be made available. We will be taking questions and doing a Q&A. Can I ask, please, that we'll do that at the end. Can I ask, please, that you use the Q&A box or the Q&A button at the bottom of your screen and put in your questions in the Q&A function. Ideally, also, if you could mention which slide your question relates to, that makes it really easy, or much easier, I should say, for Simon to field the question and understand the context in which it's being asked. If you're willing to do so, if you could put your name in when you ask a question as well. I won't share that when I field the questions and ask the questions to Simon, but it does mean if we don't get to your question, we are able then to respond to you personally with an answer to your question. Feedback really important from our perspective. Obviously, we need to know what works and what doesn't work. And equally importantly, it's really helpful for us to hear from you with ideas about what you would like us to cover in future sessions. It makes our lives much easier in the regular planning sessions we have if we've got feedback from you telling us what you want to hear about. So please do take the opportunity to do that. So that's more than enough from me. I'll hand over to Simon. Simon, thank you.
Thank you, Alex, and hello, everyone. As Alex said, I'm going to cover a number of issues in relation to generative AI. Firstly, I'm going to provide an understanding of what the technology actually is and how it works within a business context, how it's applicable to the legal sector, including giving you use cases for both lawyers and non-lawyers, and then highlight some of the key challenges and issues that you may face when implementing generative AI solutions, and importantly, how you might overcome them. I will be using some technical terms, but I'm going to try and keep it as business focused as I can and not get dragged into too much technical detail. So, what is generative AI? Well, it's a form of artificial intelligence capable of creating new content in various forms. That's including text, images, computer code, and most recently, the ability to create video. It typically takes its input in the form of natural language user prompts. And the most famous example application that you'll all be very familiar with is ChatGPT. That's an alarm going off in your Cambridge office. Sorry about that. Generative AI uses machine learning techniques known as neural networks, and these are loosely based on the way the human brain works. So they're able to process information to analyze common patterns of arrangements in very large sets of data. That's a key point. And then use that information to create new outputs. Large language models, or LLMs, and I'll be using that term a lot throughout this presentation, is the name given to the GenAI models that result from this machine learning based training. So Large language models are at the foundation of all the generative AI solutions that I'll be talking about today. You may have heard of some of the LLMs, things like OpenAI's GPT-4, Google's Gemini, Anthropic's Claude 3, Meta's Llama. I'm not going to get into any real technical detail as to how these LLMs are actually created or how they work. To be honest, that's far too technical for me and for this discussion. However, it's worth saying there's nothing particularly sinister behind them. They are essentially just very, very sophisticated predictive engines. And it is worth explaining what I mean by that. Large language models, or LLMs, learn to predict the next word by recognizing patterns in enormous quantities of text, a process that's called self-supervised pre-training, i.e. the P in GPT. Today's large language models use huge volumes of data drawn from various sources across the internet, such as Wikipedia, books, social media, internet forum discussions. And actually that equates to petabytes of data, or hundreds of billions of what we call parameters tokens, or for the purpose of this presentation, think about them as words. So how do these LLMs learn? So let's take an example of the nursery rhyme Mary Had a Little Lamb. During the training, the LLM looks at the first word, in this instance, Mary, and then tries to predict and guess what words come after it. The LLM's prediction is compared with the actual next word as it appears in the data that's presented on the internet, in Wikipedia, in the social media, or whatever. When correct, the model then looks at the first two words in the original text and tries to predict the third one, and it goes through that process until it completes the prediction across the whole body of the text that it's learning from. This process is what the word learning refers to in the phrase machine learning. This is what trains the vocabulary and capability of the large language model to understand natural language inputs and produce natural language outputs. Importantly, it's also the reason why sometimes these generative AI solutions and large language models can get things wrong, because it can make the wrong prediction if it hasn't been trained on that content. And this is something that you may have heard of as referenced as hallucinations. It's also the reason LLMs become more sophisticated as you provide them with more information. So LLMs are predictive engines capable of producing natural language, and they're really, really good at it. In reality, there's a lot more to them, the next word prediction, but this capability is a core part, and it's just really worth understanding. Let's talk in more practical terms about how generative AI solutions are architected and what they're used for. In this slide, I'm trying to show you how generative AI solutions that you may be able to buy in the marketplace or that may build yourselves are actually architected. And to do this, I'm going to use an analogy. So on the left-hand side, you have electricity as the underlying technology that drives certain applications, such as a washing machine. And a washing machine is good at delivering certain use cases, such as washing clothes. In the generative AI sense, the equivalent to electricity is the large language model. The large language model underpins the applications, such as ChatGPT, which are good at delivering certain use cases, such as summarizing the content of a document. So different applications sit on top of the large language model and are good at different use cases. For example, some like ChatGPT are good at summarizing documents. Some like Copilot GitHub are good at producing computer code for software engineers. DALL-E is good at producing images. And a product like Luminance is good at analyzing legal contracts, while a product called Harvey may be good at doing legal research. So as electricity drives household appliances, large language models drive generative AI. And in the same way that you have multiple providers of electricity, we also have multiple providers of LLMs, or multiple LLMs. The important thing in this analogy is to ensure that you're using the right application for the right use case. You wouldn't use a washing machine to heat food, and in a similar way, you wouldn't use certain generative AI applications to do certain things. For example, and I'll explain more about why this is the case later, You wouldn't use ChatGPT to analyze a legal contract. Why is generative AI and this generation of technology any different from ones we've seen before? There's a lot of interest and noise around generative AI at the moment, but is it actually going to deliver on some of the promises that we read about in the legal press? Is it going to transform the way that lawyers work? Is it going to transform the model for in-house legal departments or for private practice law firms? Is it going to, in some instances, remove the need for lawyers? We've seen a number of cycles of technology over time that have promised to do similar things. We saw the rise of the internet in the late 90s, the rise of cloud computing in the noughties, and actually a previous generation of artificial intelligence that we saw 7 or 8 years ago, all promising to transform the industry, but actually probably to some extent being a bit disappointing in what they actually delivered. So is GenAI different? Is it actually going to deliver real and significant change to the sector? So first of all, generative AI works in a way that lawyers work. It consumes natural conversational language and outputs natural language. So it's got a familiar interface and a familiar output for lawyers. Importantly, it also doesn't require huge amounts of training in order to make it work. If you remember the AI technologies I mentioned just a second ago that were about 6 or 7 years ago, the sort of technologies aimed at doing contract analytics against large volumes of documents as part of a document or review or due diligence exercise, those tools required lots and lots of training, and they required lots and lots of involvement from technical teams to set up. As such, there were lots of barriers to adoption. That's not necessarily the case with generative AI. Those tools also used to produce outputs that we were able to understand and interpret. They weren't particularly useful, just long lists of terms or spreadsheets full of terms. So they were difficult for lawyers to navigate and understand. As I said before, generative AI produces new content in natural language form, in images and video, so formats that can be easily understood and consumed. Also, the earlier versions of artificial intelligence were really only suited to one business case, and they were expensive. So trying to justify the cost of one solution, an expensive solution against one business case, was difficult to do. So generative AI, I'd argue, is potentially different in that it doesn't require lots of training as previous technologies did. It doesn't require large technical teams to get involved to get you able to use them. And generative AI solutions can deliver against a broad set of use cases. So the business case for buying a generative AI legal assistant, for example, is potentially more justifiable. So in essence, a lot of the barriers for adoption and change that we saw in previous iterations of legal technology may not be there with generative AI. So I think the potential for radical change is there. And then you've also got companies like Microsoft, and we'll be talking about that. I'll be talking about that more later, are consumerizing generative AI technology through their Copilot products. So it's difficult to see how the technology is ultimately not going to impact us all. So there's a lot happening in the market. It's a very, very dynamic market. There are a lot of new startups, literally hundreds, and huge amounts of venture capital being invested. We're seeing significant amount of investment from existing legal technology companies with new announcements recently from providers such as Intapp, iManage, and Latera. As I said, it's a very dynamic environment with things virtually changing on a daily basis. And there's also lots of activity from private practice law firms. We've seen lots of firms announcing generative AI solutions that they've developed, and even in some instances taking those to market, such as A&O, and others announcing strategic implementations of generative AI, specific generative AI products such as Harvey, Spellbook, and CoCounsel. And we've seen firms announcing full global rollouts of Microsoft Copilot 365. So there's a huge amount going on, a massive amount of money in it, and it's very, very difficult to keep track of it and subsequently make sense of it. I wouldn't believe everything you read. There is some smoke and mirrors. I know what some firms are doing, and I wouldn't necessarily believe everything, as I say, that you read, but it is really exciting and I think potentially game-changing. Moving on. So let's talk a little bit more about large language models. As I said before, large language models are the foundation of generative AI solutions. most of the large language models, including the ones that support the generative AI applications that you'll probably be familiar with, like ChatGPT or maybe more recent Google Gemini, are built from publicly available data. And this is a really important point. ChatGPT uses the GPT-4 large language model from OpenAI, while Google uses its own Gemini LLM. These LLMs are trained on very large volumes of content from the internet, as I said before, things such as Wikipedia, books, social media, internet forums, etc. But it's all content that is publicly available to everyone. So I like to use the analogy to describe what capability access to this type of an LLM is giving you as direct access to a team of assistants. So direct access to a large language, GPT-4 is the equivalent of each of us having real-time access to a team of assistants. That's not just one person supporting you. It's a number of people, because these large language models are very, very scalable. They can do things very, very quickly, and they can take on large volumes of work. And they've got certain characteristics. For example, GPT-4 has been measured as having an IQ of 155, which apparently is a really high IQ and higher than me, certainly, and apparently your average lawyer. LLMs can understand and speak many different languages and can translate from one language to another. And because they've been trained on large volumes of content, they do actually have a massive amount of general knowledge. So they know quite a lot. They know an awful lot, in fact. And because they run on computers, unlike people, they can work 24/7. They don't get tired, and they don't get frustrated or bored. So for me, the analogy is access to an LLM is like access to a pretty capable and scalable group of assistants. And why wouldn't we all want that? But there are some caveats to that. These incredibly capable assistants with the high IQ and the ability to speak multiple languages have constraints. And these are critical points to understand. As I said before, large language models have been trained on large volumes of information, giving them a broad understanding of language, the world, reasoning, and text manipulation. But their knowledge is essentially stale, with each model, LLM, having only been trained up to a certain point in time. So GPT 3.5 was to September 21, GPT-4, April 23. And that knowledge is not being updated continuously. Moreover, they only typically have access to that publicly available information. As a silly example, ChatGPT doesn't know who the current Prime Minister is. So they don't really have any knowledge behind your corporate firewall. That is any information about your business, your legal department, firm that isn't currently publicly available. They don't have any knowledge about how you do your business, your best practices, the projects you're working on, etc. So ask an LLM to produce a draft summary status of an internal project. It won't be able to provide an answer, as it doesn't know the context or relevant information, because it's not publicly available. As previously explained, general LLMs do not have specialist understanding of legal concepts or terminology either. So ask an LLM like GPT-4 via ChatGPT to draft a legal contract, and it may do a semi-reasonable job, but it may not be able to. It may not be fully legally compliant, and it won't be able to adhere to your contract standards or playbook because it doesn't know what your contract standards or your contract playbook may be. And as I said before, LLMs may get things wrong and show bias because they've been trained on that publicly available information on the internet that sometimes is wrong and inherently includes bias. So their responses reflect that. And as I said, if they don't have the knowledge, they may make things up or hallucinate. And you've probably read some very high profile examples of that in the legal sector in the US. So, as with any other group of general assistants that you may have access to, you can't always absolutely trust what they produce. So you must supervise them, you must provide the oversight and review the output they provide. So in summary, LLMs trained on publicly available data provide you with fantastic capabilities, but they have significant knowledge limitations, and you should not blindly trust the output. So while great at producing first drafts of generic content, such as a role specification, for for a lawyer, for example. In a business context, we have to think more broadly than ChatGPT. And this is the critical point. When asking an LLM to create new content, we should not use them as a source of knowledge or facts. We should be using them as general reasoning and text processing engines. The training has made them capable of understanding language, of general reasoning, and producing natural language outputs. We're not interested in their stale knowledge. We're interested in their capabilities, which then leads you to the question, how do we provide those large language models with the information and knowledge to make that processing and language reasoning capability really useful and trustworthy in a business situation? As I said, right now, you have to supervise and have oversight over large language models and all generative AI solutions. The real power of generative AI comes when the LLM, the large language model, can access and process information about your business and about your legal department or private practice law firm. So how do we teach the LLMs about things we'd like them to know about our legal department and our business? And how do we also give them a better understanding of legal concepts and legal terminology? In other words, how do we turn these general assistants into more useful legal assistants, or even possibly the kind of paralegals or junior lawyers? And at the same time, how do we minimize hallucinations? How do we minimize them making things up? And ultimately, how do we minimize the number of incorrect responses we get? And there are two main approaches that are applied either in generative AI products that you may buy or how you may develop generative AI solutions in-house that try and address those key questions. And I'm going to talk to you about both. The first is something called grounding, and the second is prompt engineering. I'm only going to touch on prompt engineering because I think grounding is much more important to how you understand, or it's much more important for you to understand when you're thinking about generative AI solutions. Again, I'm going to try and avoid being too technical, and I'll try and keep things relatable, but I do think these are important concepts if you're going to really learn how to exploit Gen AI and evaluate different solutions that you may see available in the market. So let's talk about grounding. It is a term that you may have read about, you may see in LinkedIn posts and various things. Grounding is the way in which we try and meet the challenge of leveraging the power of large language models by giving the models the necessary context and data to do their job. Grounding is the process of providing a large language model with information that is specific to the use case, relevant, and it's not part of the originally trained knowledge. In other words, we need to ground the models, i.e. GPT-4, Google Gemini, with the context for the specific use case in order to enhance the reliability and the relevance of its generated content. And there are two types of grounding. I'm going to talk about fine-tuning and something which sounds scary, something called retrieval augmented generation, or RAG. So what is fine-tuning? So fine-tuning is where the base model that has been, as I said, explained before, trained on general publicly available data is further trained on specific domain-related data to improve its ability to create content for that domain. For example, a large language model could be fine-tuned on medical texts to become more adept at generating medical information. Fine-tuning uses the same sort of process that was originally used to train the model, but it's a very technically complex, compute-intensive and expensive thing to do. So in reality, it's not something that the vast majority of organizations, so private practice law firms or your organizations or your legal departments are going to do. However, it's important to understand it because in various vertical markets, such as legal, certain software companies have taken this approach and they're using it as a key differentiator for their generative AI solutions. And I've got some examples on this slide. So Harvey and Spellbook are two generative AI solutions aimed at the legal sector, which further fine-tune the base GPT-4 large language model using large volumes of legal specific content, such as contracts, cases, statutes, rulings, etc., to make their solutions more proficient in legal concepts and terminology. So their solutions are theoretically better at understanding and outputting content that is relevant to the legal sector. Luminance is an example of where actually the solution provider has built a completely proprietary large language model. They've built a large language model that based around, I think, something like 135 million contracts that can understand different legal contract types because it's been trained on those legal contract types. So it's very specialist within that particular use case in that domain. So the key point is that your organization will probably not be fine-tuning large language models, but you may decide to use solutions that have been legally fine-tuned because their large language models give better responses to your particular legal use cases. So RAG. So while we may be using fine-tuned large language models, they'll be an integral part of the solutions you buy. You won't be directly involved in the fine-tuning process, but you may be more directly involved in retrieval augmented generation or RAG. So how does this work? RAG is an approach that will enable us to utilize our organization's business and legal content so it's more relevant to understand the thing in a little bit more detail. With RAG, we essentially provide the large language model with data and information relevant to the prompt at the point of submitting the prompt to the LLM. We could theoretically do this by manually adding information or documents to the prompt. So you write the prompt, you start adding documents to it, but that's not a particularly scalable solution. You may not know where the relevant content is. So the most scalable technique and the one most widely used by enterprise-wide generative AI applications is retrieval augmented generation. In RAG, the relevant application or solution automatically searches a database of content, retrieving the information relevant to the prompt being asked, and then appends that information that it's retrieved to the prompt. It can do this search using a combination of keyword searching or something called semantic searching, meaning-based searching. So providing information that's related to your prompt as opposed to keyword matching the prompt. So the LLM then uses that found content as knowledge to create its output using its large language reasoning when answering the prompt. So the information is added to the prompt, the large language model then can process the prompt with the context, with all the information you provided it through the search process. And there's the diagram on the right-hand side of this slide shows you how it does it. So you issue the prompt then goes and searches the database for relevant content, it returns the content, it appends it to the prompt, it then sends all of that information to the large language model. The large language model then can use its skills, its reasoning, its language capabilities against the prompt, plus all the relevant context and information relevant to that prompt, crafts its answer and sends it back to you. So, for example, I may ask a generative AI chatbot to provide me with an itinerary of travel from, say, location A to B, and to include dates, times, and prices. The solution will search the relevant database for things like flight and train information based on my request, and then send all the information to the large language model for the LLM to generate an itinerary for me based on real options and availability. And you can imagine this technique becomes quite complicated as volumes of data being searched and retrieved are larger and larger. For example, when dealing with large-scale legal content and documents. And given some limitations of LLMs around the size of the prompt window and the context, the amount of data that you're able to put within that context window, these solutions get into all sorts of clever techniques and things by taking a single prompt and chunking it up, or chunking the content of a document up and making it into multiple prompts and then stitching those prompts back together. So there's quite a lot of software engineering behind these solutions within the RAG process. But essentially all of that's hidden to you as an end user. But it's, as I say, important to understand. One useful analogy for RAG I recently read on LinkedIn explained the retrieval engine as being like the librarian that goes and finds all the relevant information, and the LLM as the highly skilled writer that uses and analyzes that information to craft the relevant and useful response. So this slide gives you some examples of generative AI prompts and how they may be grounded using RAG in different forms of data. So the first prompt is asking about the recent budget, and that would be grounded in information searched from the internet. The second prompt about an internal project may be grounded in data searched and retrieved from the Office 365 information within the corporate firewall. The third prompt, a summary report for a redline legal document, would be grounded in that document and other legal documents relevant to the question that's being asked. Fourth example, asking a question relating to a series of contracts, will be grounded in those contracts. And the final legal research question will use RAG, retrieval augmented generation, to ground the prompt in a large quantity of relevant legal content, including case statutes, etc. So a number of vendors, technology vendors, and internal IT teams in various law firms and other businesses are using grounding, and in particular RAG, to build applications that are able to distill and make sense of large volumes of internal documents and information. Microsoft Copilot 365, which you will have heard a lot about, is grounded in the content you have created using your Office 365 applications. So when you ask Microsoft Copilot a question, it orchestrates access to all the information, that's documents, emails, calendar events, Teams meeting minutes, relevant to the question, and it grounds its response in that content. And I'll explain how that works in a bit more detail a bit later on. So very briefly, prompt engineering. It's just worth mentioning prompt engineering because the effectiveness of responses you get from a large language model is also very contingent on the precision and quality of the prompts you use. In other words, what you feed into an LLM has a direct input on the outputs that we receive. The technique of enhancing a prompt is prompt engineering. It's the art of crafting and fine-tuning these inputs to enhance the performance of LLMs by producing or providing clear, specific, and unambiguous and structured will enable the model to grasp the context better and produce more precise responses. For example, write a product description for a new water bottle won't give you as good a response as write a product description for a new water bottle that is 100% recycled, highlight its natural color, the environmental benefit, etc. So prompt engineering also plays a role in reducing bias and generating fairness from the response in the AI models. In a lot of ways, I think prompt engineering is common sense, but there are some specific techniques that you may have read about, things like chain of thought, contextual priming, and scenario expansion. I won't go into them. This is an example on the screen here of something called few-shot prompting, where within the prompt you give the LLM examples until you ask it the actual prompt, and by the LLM learns from the example so that it gives it, so you get a better response ultimately. A lot of what you can do with prompt engineering is embedded within generative AI products that you're ultimately going to review and buy going down the line. And they're being crafted by specialists and software engineers. Having said that, it is worth remembering a few key points when you are inputting prompts into things like Microsoft Copilot or ChatGPT. Some key principles around prompts that will help you. So clarity and specificity, make sure that your prompts are clear and direct. Try and make them non-ambiguous. Give them context where you can, include relevant context within prompts. It will enhance the ability of the AI to understand what you're trying to achieve. Give it additional information to help the model generate more relevant responses. And refine your prompts as you get responses from the AI. Look what the AI is responding with and see if you can get it. You can adjust it as you issue more and more prompts, because the net quality of your prompts that you input will have a direct input on the quality of the response you receive. But essentially, I've talked about different ways in which generative AI solutions manipulate large language models to make their outputs more relevant to law and your business. And each of these techniques, whether RAG, fine-tuning, or prompt engineering, are all valid techniques, and many solutions will combine all three in complex, intelligent ways in order to optimize their particular solutions to the use cases that you're trying to meet. At this point, I'd like to make a very specific point around chatbots. A key difference between two chatbots tools that you may be using or considering using, ChatGPT and Copilot Chat. The latter was previously called Bing Enterprise Chat. Both use the GPT large language model, but Copilot Chat is grounded in internet content, while ChatGPT isn't. So going back to my previous silly example, Copilot Chat will answer the question, who's the British Prime Minister, because it will search the internet and get the response and then craft a response around the answer that it got from the internet. ChatGPT can't answer that question because it isn't grounded in internet search. Also, if you're using Copilot within a commercial Microsoft 365 license, as your organization probably will be, then you have commercial confidentiality protection at no extra cost. Your own inputs won't be used to train the model, and your data will stay inside your firewall. So if you are considering or having made a general chatbot available to your teams, you may want to consider what I'm saying here and use Copilot Chat over ChatGPT. So thinking about use cases, and we've done quite a lot of thinking about this at Mills Reeve. So we think about use cases in three broad areas: general efficiencies, the business of law, and the practice of law. All of these use cases require RAG to make them work. In other words, content is made available to the LLM to make their responses more relevant and to make their capabilities in terms of language manipulation and reasoning more relevant. So the first set of use cases, general efficiencies, they're relevant to anyone and any role within an organization and can make anybody more efficient, essentially through the use of generative AI. And our sense is that these types of use cases will largely be fulfilled through products like Microsoft Copilot 365, as it's through the Microsoft applications that much of this type of general work is done. And I guess everybody in this webinar is a 365 user. So these are use cases that aren't domain or role specific. And I've got some examples on the slide here, which I won't go through, but things like summarizing long documents, summarizing drafts of emails, creating first drafts of documents, creating PowerPoint decks from documents, etc. We've been testing Copilot 365 over the last few months, and while it's definitely not a finished article, it does have some fantastic capabilities, and it is improving almost on a daily basis. I've used it for all the use cases I've just mentioned. For example, I've taken a long document and turned it into a very decent first cut PowerPoint presentation with over 30 slides, and I did that in less than 2 minutes, so it saved me hours. Did a pretty good job. Still needs some fine tuning, and the output needs to tweak it, change it, put it into house cell, etc. But it did a pretty good job. We've also particularly found the Teams functionality in Microsoft Copilot 365 really, really useful. Being able to turn around the minutes from a meeting and the actions in relation to that meeting really quickly, allowing people to get a good understanding of what happened without having to attend that meeting. The second broad category of use cases relates to the business of law, and these are the tasks that usually I think data intensive that lawyers either in legal departments or private practice firms typically don't like doing, but they're necessary and they impact areas of things like risk and compliance, budgeting, pricing. These processes need to be executed consistently across the department or firm, and in order to provide meaningful output. And they must importantly use curated content. There's no point asking a generative AI solution to produce a first draft pitch document based on your firm or your department's standards or your law firm's standards if you don't provide it with the best examples that you've got. Examples of this sort of area also may include things like analysing bills for compliance against agreed terms, producing risk assessments for particular deals, etc. And in private practice, it also will help in areas such as conflict checking and pricing. The third category is the very, very critical one, obviously, and it relates to the practice of law. And so how do we enable lawyers to be more efficient and improve the quality of client service? And there are literally hundreds of potential use cases including first drafts of documents and summarizing legal documents. GenAI can help in lots of areas around contract analysis, review and drafting, legal research, lots of stuff in the area of e-discovery. So GenAI can assist in document review processes, able to review very large volumes of content, producing evidence-based answers to questions, compliance and regulatory monitoring. And I'll talk in more detail about some of these practice of law uses with a few more examples later on. So just talking about general efficiencies and Microsoft 365. Microsoft Copilot 365 is a tool that sits inside, or potentially, if you buy it, sits inside each of your Microsoft 365 applications. So there's a Copilot within Word, within Excel, within Outlook, within Teams. So you go into PowerPoint, for example, you open Copilot and ask it to produce a presentation based on a specific document. Or when in Word, you can highlight a paragraph and ask Copilot to rewrite it in a particular style. You can open a long document in Word and ask it to summarize it. The important thing is, how does it work, and why I was talking to you about grounding before. Well, the real power of Microsoft Copilot 365 is that it orchestrates access to all your content your business has created using Office 365 for the LLM, which is actually just GPT-4, the same LLM used by ChatGPT and a number of other tools. So all your Microsoft content is held in something called the Microsoft Graph, and this is searchable through something called the Microsoft Semantic Index. So when you ask Copilot something like, find out what Simon Thompson has been doing today, which you can do, or what is our firm's strategy, it will go out and search everything in the Microsoft Graph, all the content you produced with 365, and it will find that content and provide it as context to the prompt, and then we'll go and ask the LLM to craft and construct an answer for you. Copilot respects the underlying security of your Microsoft content, whether that's emails, Teams, chat, or documents in SharePoint or OneDrive. But, and this is a really critical point, while it's great at what it does, it emphasizes the need to have those access controls properly in place. Otherwise, the powerful search capability of Copilot may unearth content that some users should not be able to see. So if you don't have control over your access and asking questions like, what's Simon Thompson earning, it could give you an answer, because it could go and find content if it's not locked down properly, which is highly confidential. So moving on to the business of law and how to improve efficiency in certain defined processes or activities. I provided a few examples on this slide, some of which relate to using first recipe types of content, such as social media, job specifications, and others relate to summarizing lots of content, such as multiple responses to an RFP you may have sent out. While others are activities that require the processing numbers of documents or contracts, for example, reviewing invoices against billing guidelines to find outliers. I think there's a huge amount of potential for generative AI to assist in these data-driven, resource-intensive, and often time-consuming and frustrating processes. The key points here are that you need to ensure that the processes are executed consistently and that they utilize curated, approved content in order to ensure the responses are reliable and relevant. So in simple terms, as I said before, there's no point asking generative AI to produce a draft, contract, or proposal if the examples you give it are bad examples. So this again puts large emphasis on quality of data and using predefined workflows to drive prompting. To build your own solutions, I've provided architectures to explain how this may be done, but it's much more likely that you'll see technology vendors that play a part in delivering these sort of solutions to you now. People like Intapp, people like iManage, building generative AI into their solutions. And it's those tools that you'll be using to meet your requirements in these sort of areas. So this is an example architecture that you could build. So your curated content, the prompt is able to, using reg, search that content and then append it to the prompt in a very similar way that I described to you previously. And some of these solutions are able to achieve this by integrating into the Microsoft Copilot infrastructure, by producing Microsoft Copilot add-ins or plugins into things like Word or PowerPoint or Excel, and then putting their data into the Microsoft Graph so that you can use the familiar Microsoft Copilot tool to then analyze and interrogate your curated data. So, and this is the key point, as I try to explain, the effective application of generative AI will require the right information to be available to the generative AI application. For example, an application that's designed to produce a first draft proposal picture should have access to the best example pictures and proposals, an accurate agreed supporting information, deal credentials, etc. To perform legal research, it should have access to approved, verified legal information sources. To review a body of contracts, it should have access to the right contracts and approved contract labels and standards. So the challenge in a lot of instances is to limit the generative AI application to access only approved sources and to ensure that it doesn't have access to other information that could negatively impact the quality of the output. And that's why Microsoft Copilot proposes a challenge, because Copilot is aimed at delivering general efficiencies. It's for all types of users across all content service producing Microsoft Office 365. When responding to prompts, it searches everything I've said before, and it can find content that theoretically is highly confidential. And it's also possible to add content into that 365 environment with connectors for things like products like iManage or other tools. So while it respects the security of information and the access rights when surfacing that content, it's very important that our content in SharePoint, OneDrive, iManage, and things like that is properly secured. If not, a prompt, as I said before, such as what salary does X earn, could surface an answer which you don't want, while queries related to matters could surface content related to confidential matters. And in fact, my understanding is a number of firms have pulled back on their implementation of Microsoft Copilot with fear that they're starting to breach information. They've got the potential of breaching information security barriers, etc., and focusing more time now on getting the security of their content right before reinstalling and re-implementing Microsoft Copilot. So moving on to the practice of law. As I said before, there are literally hundreds of potential use cases within the practice of law. Firstly, and I won't go through them all of them, but drafting legal documents. Generative AI can assist in creating legal documents such as contracts, pleadings, briefs. By drawing on existing templates and precedents, it can create, customized content while maintaining accuracy and consistency. It can also check existing documents for accuracy, consistency, and potential legal issues. So, for example, prompting it to produce a first draft contract for client X using our contract standards, or to redraft this clause using our contract standards and based on this particular negotiating position. So there are lots of examples where generative AI can help within the contract lifecycle, summarizing changes to redline contracts, uploading contracts on third-party paper and identifying clauses that conflict with your policies, identifying drafting, replacement wording for clauses based on changes, identifying critical dates and deadlines across body contracts. Generative AI can help in due diligence document review, and clearly, if it's grounded in the right content, can help in legal research and knowledge management. It can search through large volumes of legal documents, such as case law and precedents, to find relevant information, extract insights, and generate summaries of reports. And it can clearly help, as I've seen with some examples, in the discovery process, being able to review, again, large volumes of content and identify relevant content and produce evidence-based answers, i.e., outcomes. Compliance and regulatory monitoring is another area. GenAI can monitor evolving regulations and ensure that you remain compliant with relevant laws and industry standards. The main point I'd like to make is that these solutions that are designed for legal use cases will be either using fine-tuned LLMs and/or using RAG, retrieval augmented generation, to provide the relevant legal context. So data becomes absolutely critical. I think there are two main types of solution in relation to the practice of law. Firstly, products aimed at delivering end-to-end solutions, where the legal process is well defined. So things like contract review negotiations, so products like Luminance in that space, and Kira. And then things like in the discovery space, like Disco and Concilio. As an example, one e-discovery technology provider I've seen looks like they're really taking tech-enabled litigation discovery to another level through its GenAI solution. Solution I've seen enables natural language queries against huge volumes of content or evidence, and it's able to process that in seconds as opposed to days using traditional techniques. So I've seen an example where 1 million documents were queried and results produced in a matter of seconds. And these are queries, very fact-based questions that you're asking about content, like why did this particular event happen, or what key events occurred during a certain date range, or was this person involved in this event? Really, really impressive. The second broad area are legal assistance. So these are the more general tools that provide lawyers with particular functionality that are part of a disaggregated legal process. So products in this space that you'll have read about and heard about, things like Harvey, Spellbook. These tools appear in a similar way to a chatbot and are using a combination of legal-specific LLMs, RAG, and complex prompt engineering to deliver legal-specific skills or tasks, some of which I've talked about earlier. This is an interesting study which you might read about. You can get access on the internet from a technology company called Onnit, where they looked at generative AI reviewing contracts versus junior lawyers and legal process outsourcers. Just very, very briefly, what they found is that the large language model outperformed both junior lawyers and LPOs in terms of both identifying, locating, and determining legal issues across a body of contracts, and critically, it was much, much faster at doing it. It's worth reading and looking at this particular case study. I'm not saying that this is suggesting that generative AI will replace lawyers, but it's worth having a look at because it is really, really interesting. And moving on to confidentiality and copyright. I'm not a lawyer, so I'm not going to spend a lot of time on these issues, but clearly they're valid and real concerns about confidentiality and copyright. Some generative AI solutions use prompts provided to further train their models, and if these prompts use firm or client confidential information, there is a risk that confidential data could become public. Using prompts provided to train LLMs is very much solution specific, so take this into account when choosing which tool you use, and make sure you look at the T's and C's. Again, copyright is an issue. Again, you need to look at the T's and C's and the various providers. I'm not going to go into detail of these. There are some basic, practical steps you can make to try and avoid poor use of generative AI technologies in your organization. So only use private or secure versions of LLMs. Don't use consumer versions like ChatGPT, which may train their models on your confidential information. Use LLMs that are fine-tuned to your specific sector. Use ones that have come from reputable organizations. Use curated content. Be very conscious of the content that you're providing to that LLM. Make sure the access rights are appropriately secured around that, and make sure that your rules are publicized and everybody's aware of them. So, in conclusion, what are the key points around generative AI and the use of it within the legal industry? So it's got some fantastic capabilities, and if applied correctly, could deliver some significant benefits to both your legal department and your law firm. So I don't think it is all hype. Large language models are not knowledge bases. Don't use them as such. You need to use things like prompt engineering, grounding to make their outputs more viable and useful. And different solutions work for different use cases, so select the right solution. Microsoft are consumerizing generative AI, so it's not going away. And I think typically you will be taking a buy and not a build approach, and those solutions will be using some of the techniques I've described. Make sure you consider confidentiality and copyright when selecting solutions. And these points are all critical. Data security and governance. You've got to get that right if you're going to use generative AI solutions effectively within your organization and produce relevant outputs to your business and your business use cases. But you could be exposing confidential information, so make sure you've got security and governance right. Education and training of your users is therefore going to be absolutely critical, and you need to supervise and review the output from your solutions. As you would with any group of assistants that you may have, you're not going to blindly trust their output. You can't do that with generative AI solutions either. And ultimately, not for this today, but what is the impact of generative AI and the impact in the role in terms of how the role of lawyers may change and how we may change, train the new generation of lawyers, given that a lot of maybe the more commoditized work that lawyers do will be replaced by generative AI going forward. And importantly for you guys, what expectations do you have, private practice law firms, in the use of generative AI? and how will that impact how law firms price their work and deliver work to you. So I think that draws my bit to conclusion. I know if we run over on time. Hand back for questions.
Simon, thanks very much. Some really fascinating and detailed and very valuable, I'm sure, insights in there. Apologies to everybody, we have run over time, but I can see that there's still more than 200 people in the meeting. So I think that's a good sign that the content that Simon's delivered, the issues he's addressed today are relevant, important, and the stuff that you wanted to hear about. We have had a number of questions. We don't have very much time to go through them, but broadly they fall into two categories. The first category relates to the updating of LLMs and ensuring that the AI tool being used has access to up-to-date relevant information. I think most of the questions that have been asked in respect of that were actually then subsequently answered by Simon when he addressed the grounding techniques, whether it was fine tuning or whether it was the RAG augmentation. So I don't think.
I think there are just two key points there, as you say. One, the large language model does not need to be trained on your business content in order to make the answers relevant. Use RAG to do that, as I've described. And secondly, make sure you read the T's and C's of any provider, because even if you're using RAG, they could be training their model on your prompts, but they don't all do that. So commercial variants of ChatGPT doesn't train the large language model. If you're using the consumer model, it does. But look at the T's and C's and make sure that you address that particular point.
Yeah, and that's the second category of question relates. Most of the questions actually will be related to these concerns about ensuring that confidentiality in inputs, confidentiality in grounding data made available to the tool is maintained as confidential. Simon's briefly addressed the high level kind of things that you need to be aware of in relation to that. To be honest, rather than try to give any more generic insights in relation to that, I think that's a session, an in-house in focus session of itself. To be quite honest, there are a number of ways that this can be approached. I don't think we can do it justice in a Q&A, unless Simon disagrees and thinks there are a couple of kind of main points that you'd like to reiterate in relation to that.
Well, I just want a couple of points maybe. So I believe you're likely to be buying your generative AI solutions from technology vendors, whether they're people like Thompson, Reuters, and LexisNexis, or some of the startup organizations like Harvey and Spell. They use private instances of the large language model for yourself, for your organization. So there are lots of security rules applied to that large language model. It's only for your own organization. It's separated out from any other large language model. And secondly, so you're not feeding into a general model that everybody else has access to. It's only accessed by your business. And secondly, as I say, they have all sorts of rules around training their models. And if you buy the right products and you read the T's and C's and apply the T's and C's, then they will not be training their models on your inputs. And they will be doing things like deleting your prompts within 24 hours, or deleting your content from the vicinity of the model within a certain time period. So there are various protections that you can have, but it's not the same as just using the standard version of ChatGPT that you see that's publicly available.
Simon, thank you. We are now well over time. As I've said, we probably will look at doing a further session which addresses in some more detail those concerns around confidentiality. Can I ask, please, if you do have time, I know we've gone over, please do fill in the feedback form, suggest either refined or more detailed content in relation to Simon's presentation that you'd like us to address, issues such as confidentiality or other topics which would be useful for you to hear about, completely unrelated to AI, which I know has tended to dominate the agenda for In-House in Focus over recent months. But again, thanks very much to Simon for all the time, effort, and your very valuable insights into what I know is a key issue which many of us are grappling with at the moment. Thanks everybody who's still on for taking the time to attend the session, for staying on until the end to hear Simon's insights. look out for the emails coming around for the next session, which will be addressing the forthcoming Procurement Act, and particularly some more insights we now have in relation to the transparency issues, which will need to be complied with to comply with the Procurement Act when it comes into force later this year. Again, thank you very much, and hopefully we'll see you next time.